Welcome to this GCSE Physics topic on atomic structure. In this lesson, we'll explore the structure of atoms, radioactive decay, nuclear radiation, and the processes of nuclear fission and fusion. Atoms are incredibly tiny, with a typical radius ranging from 30 to 300 picometers. The atom's nucleus is unimaginably smaller than the atom itself, measuring only about 1 × 10⁻⁴ meters across. Atoms are the fundamental building blocks of all matter. Every atom features a dense central nucleus surrounded by orbiting electrons in defined energy level. Atoms are made up of three main subatomic particles, protons and neutrons in the nucleus, and electrons in energy levels surrounding the nucleus. Absorption and emission describe how electrons transition between discrete energy levels in an atom. Electrons can only exist at specific, quantized energy levels. Electrons generally occupy the lowest available level, called the ground state. An electron absorbs a photon with energy equal to the difference between levels. Excited electrons return to a lower state, releasing the energy as a new photon, which corresponds to the energy gap. The atomic number defines the element. The mass number is the total number of protons and neutrons. The atomic number, mass number, and charge define the structure and behavior of any atom. Together, they determine the element, its isotopes, and how it interacts electrically. Isotopes are atoms of the same element that vary in the number of neutrons. Stable isotopes have stable nuclei that do not emit radiation or decay over time, while unstable, radioactive, isotopes, also known as radioisotopes, have unstable nuclei that spontaneously emit particles and radiation to achieve a more stable state. Ions are formed when neutral atoms lose or gain electrons, resulting in an unbalanced electrical charge. While the atom's protons and neutrons remain unchanged, the change in electron count alters the atom's charge, allowing it to achieve a stable, full outer energy level. Atomic theory evolved over time. Dalton described atoms as solid spheres. Thomson discovered the electron. Rutherford proposed a nucleus. Bohr introduced electron shells. Finally, Chadwick discovered the neutron. To calculate the number of protons, neutrons, and electrons, you need the element's atomic number and mass number. The atomic number is the smaller whole number in an element's periodic table box. It defines what the element is. Radioactive decay occurs when unstable atomic nuclei release energy in the form of radiation. The main types are alpha particles, beta particles, and gamma rays. As penetrating power goes up, ionizing power goes down. Alpha radiation travels only a few centimeters in air. Beta particle is an electron ejected from a nucleus when a neutron becomes a proton. Travels tens of centimeters in air, and gamma radiation travels very large distances. Nuclear equations represent radioactive decay. The total mass and atomic numbers are conserved. In this example, uranium emits an alpha particle. Half-life is the time it takes for half the radioactive nuclei in a sample to decay. This process is completely random but statistically predictable. Radioactive contamination occurs when radioactive substances land on or in materials. It's different from irradiation, where objects are exposed to radiation without contact. We are constantly exposed to background radiation from natural sources like rocks and cosmic rays, and from artificial sources such as X-rays. Different isotopes have different half-lives. This affects how they are used, whether for short-term medical scans or long-term radioactive dating. Nuclear radiation has many uses, from detecting cancer to sterilizing surgical tools and checking for leaks in pipelines. Nuclear fission occurs when a large nucleus splits into smaller nuclei, releasing energy and neutrons, which can trigger more fissions, a chain reaction. Nuclear fusion joins light nuclei to form heavier ones. This process releases vast amounts of energy and powers the sun and other stars. In this topic, we explored atomic structure, radioactive decay, and nuclear processes. Understanding these concepts is vital for both exams and real-world science. Thank you for watching.